Dear students, in the present class, we discuss about the overall cost structure of a firm, or we define what is known as the cost function. Now it is known to you that cost functions are derived functions. Cost functions are derived from production function, and there are various ways in which cost functions can be derived, but we use the expansion path solution to derive the cost functions. And we start with the total cost function. We start with the total cost function. Total cost function shows that for any set of input costs and for any output level, the minimum cost incurred by the firm, or it is defined as the minimum cost to produce any level of output given the factor prices, and it is written as C of QW. Total cost function is written as total cost is a function of quantity produced, wage rate, and rate of interest. And as it is known to you, suppose that this is the expansion path. The expansion path is OE, capital and labor. Each isoquant represents a particular level of output. Naturally, as output increases from Q1 to Q2 to Q3, the successive cost also increases. ISO cost line represents total cost of producing output Q1, Q2. This isoquant shows the cost of producing Q2, Q3, etc. So, if you plot quantity here and total cost here, you will get a relationship between total cost and quantity derived from the expansion path solution. So as you can see, total cost increases with the output. The shape of the total cost curve depends on the nature of the production function. Now we begin by analyzing the relationship between total cost and output, keeping factor prices constant. That is, C as a function of Q, keeping W and R constant. And then we consider how a change in input prices cause shift in the expansion path and thus the cost functions. Initially, we consider the relationship between cost and output. Then we consider what happens to cost when factor prices change, or what happens to the expansion path as W by R changes and its impact on cost functions. As it is known to you, these points represents equality between MRTS and factor price ratio. When W by R changes, MRTS also changes. When MRTS changes, K by L ratio changes because MRTS is equal to MBL by MBK. So there will be a shift in the expansion path depending on the nature of the change in W and R, and there will be a corresponding shift in the cost functions also. Now, although the total cost function will give us complete information about cost output relationship, it is convenient to analyze cost in per unit output terms. It is convenient to analyze cost in per unit output basis, because per unit analysis corresponds closely to what is known as the analysis of demand, where we study price per unit. So, once the total cost function is given, we derive the per unit cost goes, so that it will be in correspondence with what is known as the analysis of demand, which states quantity demanded as a function of price per unit. Also, as it is familiar to you, in a perfectly competitive market, marginal cost above average variable cost is the supply curve of the firm. The supply curve of the firm. And what happens to quantity supplied as price successively increases. So we concentrate on per unit cost curves. We consider both marginal cost and average cost. Two per unit cost curves, average cost and marginal cost. Now, given the total cost function, the average cost function is a function of QWR is equal to CQWR by average cost is total cost divided by quantity. Total cost divided by quantity. That is the per unit cost curve. Now, marginal cost, MC, marginal cost function, is written as MC QWR is equal to dou C QWR by dou Q. That is the derivative of the total cost function with respect to quantity. So, in these definitions of AC and MC depends on the level of output Q on the one hand, and also factor prices on the other. So, like total cost, marginal cost also depends on the level of output and also factor prices. Also, we can graph the relationship between cost and output on a two-dimensional space, keeping prices of inputs constant and also assuming that technology will not change. This is what we usually do in microeconomics. We plot total cost as a function of quantity in a two-dimensional space keeping factor prices constant and also assuming that there is no technological change. Assuming that there is no technological change. Also, if factor prices change and also if there is technological change, what happens is total cost curves will shift to new positions. So the position of the total cost curve depends on factor prices and the level of technology. Now, a simple relationship is given like this. Total cost is a function of quantity, total cost, and the corresponding quantity MC, AC is equal to MC. This is the graph of total cost, and the corresponding MC and MR are given. Now, as it is clear, in this specification, total cost is proportional to output. Total cost is proportional to output. So we can write it as AQ with the average cost and also marginal cost equal to A. That is TC by Q is equal to dou TC by dou Q equal to a constant. AC is equal to MC is a constant. Now, such a proportional relationship between total cost and output is obtained if and only if the underlying production function exhibits constant returns to scale. That is, if and only if the underlying production function is linearly homogeneous. Remember this? Homogeneous is not enough. Linearly homogeneous is required for the total cost to be proportional to output and MC is equal to AC, a constant. MC is equal to AC, a constant. Now let us consider this statement with an example. Suppose that to produce 1 unit of output, K1 units of capital and L1 units of labor is required. That is, C Q is equal to 1 is equal to R into K1 plus W into L1. Assume that to produce 1 unit of output, K1 units of K and L1 units of L is required. So the cost of producing 1 unit of output is R into K1 plus W into L1. Then to produce M units, M into K1 units of K and M into L1 units of L will be required. So that cost of producing Q is equal to M is equal to R into M K1 plus W into M L1. So that it is equal to M into R K1 plus W into L1 is equal to M into cost of producing Q is equal to 1. So proportionality between cost and output is established. If 1 unit of output requires K1 and L1, M unit of output requires M times cost of producing 1. So if 1 unit of output requires a cost equal to 100, to produce 100 units, cost becomes 100 into 100, that is 10,000. So only in the case of linearly homogeneous production function, and this production function satisfies the fact that it is linearly homogeneous. Only if the production function is linearly homogeneous, not homogeneous, homogeneous, then we have a proportional relationship between cost and output, so that AC and MC is same. TC by Q is equal to dou TC by dou Q is equal to A. But this is a very simple cost output relation. We do not expect that the cost output relation will be like this always. Let us see a little more complicated cost output relation. Like this. Quantity, total cost, and as it is known to you, the standard shape of the total cost is like this. So that MC, marginal cost, and average cost, like this. Suppose this is the most realistic shape of the cost curve. The corresponding MC and AC are given. Now, what is peculiar about this total cost curve is, initially it is concave up to point A, so that MC is decreasing. Beyond that it is convex, then MC is increasing. A is known as the inflection point. So initially TC concave, and beyond a point it is convex. That means the cost increases at a diminishing rate, so that MC decreases. Then cost increases at an increasing rate, so MC increases. AC decreases continuously for some time, then AC increases. Now, the question is, why total cost become convex beyond point A? One reason suggested is the existence of a third factor entrepreneur. Initially, at lower levels of output, what is suggested is, as the output is moderate, entrepreneurial services will be optimum, but beyond a limit, entrepreneurs will not be able to manage output properly, so that it becomes suboptimum, and there will be diminishing returns to managerial services. This is one reason for suggesting that initially cost increases at a diminishing rate, then cost increases at an increasing rate. Of course, there are other explanations too. This is basically an empirical question. If you have the cost and output relating to an industry or a firm, you have to estimate it. Then only you can establish the cost output relationship. And the equation of a standard total cost curve can be written as A0 plus A1Q plus A2Q square plus A3Q raised to 3. A cubic total cost function. A cubic total cost function. For getting this shape, restrictions should be placed on A0, A1, A2, A3, etc. A0, A1, A2, A3, etc. That is, and there is one issue here. In the graph, the total cost starts at 0. Actually, the total cost actually starts somewhere on the y-axis, and this is the fixed cost. And in terms of the equation, A0 is the fixed cost. In that case, it will become total variable cost, and there is a total fixed cost. This is total variable cost. Adding together, you will get a total cost. Total cost. And this distinction is relevant only in the short run. The shape is same, no difference. The standard form of total cost curve is this. This is the fixed cost, and this part is the variable cost. And as it is clear to you, the shape of MC and AC is like this. Initially both decreases, then increases, and MC reaches the minimum first, followed by AC. And also it is known to you that MC intersect AC in its lowest point. Also, as long as MC is lower than AC, AC is decreasing. When MC is above AC, AC is increasing. When MC is equal to AC, AC neither increases nor decreases. These are points familiar to you from our earlier classes. And as we have derived in the case of average product and marginal product, you can differentiate AC with respect to Q. That is, dou C by Q with respect to dou Q. That will give you Q into dou C by dou Q minus C into 1 by Q square is equal to Q into MC minus C by Q square and 1 by Q into MC minus AC. This relationship holds for all AC, for all average marginal relationships. When MC is equal to AC, slope of AC is 0. When MC is greater than AC, slope of when MC is greater than AC, slope of AC is positive. MC is greater than AC, slope of AC is positive. When MC is less than AC, slope of AC is negative, like this. So this is the cost function. Remember, this cost function is a function of output and factor prices. When we draw the cost functions, we assume that factor prices are constant, and we specify the relationship between quantity and cost. Since in the market, demand is specified in terms of price per unit, we will not use the total cost relation to describe the cost function of firms. Instead, we use the per unit cost curves, the MC and AC curves. This is the cost functions.